Hey guys, I'm excited this morning to go ahead and get through a couple of things today. Today we're going to be talking about points and vectors in three dimensions. Okay, we're talking about points and vectors in three dimensions. Now, we know that in two dimensions is what we mostly deal with in the Cartesian coordinate plane, right? We deal with length and we deal with width, right? So if we just kind of remember something with 0 dimensions, that's going to be a point, right? Because a point has neither length nor width. 1 dimension, that's just like a line, right? A line has length, but it doesn't have width. It doesn't have, it doesn't have area. 2 dimensions has length and width. So I can go, I can have area now, right? It's 2 dimensions. So if 0 dimensions has neither length nor width, 1 dimension has just length, 2 dimensions has length and width, then in 3 dimensions, we deal with not just do we deal with length, not only do we deal with width, but we also deal with height. Okay? So we went from 0 dimensions to 1 dimension to 2 dimensions. Now we're in 3 dimensions. Now in 3 dimensions, each dimension has its own axis. So you can imagine, let's say if 1 dimension, I just have an x axis or something like that, right? In 2 dimensions, I have an x and a y axis. In 3 dimensions, I've got an x axis, a y axis, and now we have a z axis, okay? And z axis will tell us the height of where we are, basically, is our height dimension. Okay. In 2 dimensions, we have these things called quadrants, right? This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4, right? We have 4 quadrants in 2 dimensions. But in 3 dimensions, we have the thing called octants, okay? And so rather than being in various quadrants, we're going to be in various octants, all right? Another thing that we see in 2 dimensions is the point, for example, the point x, y, right? We call these things ordered pairs, where the x goes first and the y goes second. In 3 dimensions, however, we don't have ordered pairs, we have ordered triples. In other words, let's say this point, let's say I've got the point, let's say this is 1, let's say this is 1, let's say this is 1. And I want to find the point 1, 1, 1. All right, and then it would go up here. So it'll be right about here. This point, we call this point 1, 1, 1. Its x value is 1, its y value is 1, and its z value is 1. It's an ordered triple. All right, so we're going to do a couple of problems here. It says determine the point in 3-dimensional space. All right, so I'm going to show you how to do that. The first thing that you're going to do, create your x and y axes. And the best way to do that is start with the y axis. So what you're going to do is you're going to draw kind of like a horizontal line. And I'm not the best artist in the world, but you all will roll with me, right? Make your y axis first. Then what you're going to do is you're going to kind of draw at an angle and x-axis. Okay, this is not really the best angle to do it at, but we get the idea. You're kind of making some kind of like perpendicular, some parallelogram little looking things, you can kind of imagine it in space. Then last but not least, you're going to create your z-axis by going kind of 90 degrees straight up, if you can. And it's helpful to kind of do it in different colors. Sometimes then you're able to see it a little bit better. All right, and that's how you create your axes. Then we're going to plot the point. So we got the point -3, -4, 2, -3, -4, 2. So to plot the point -3, -4, 2, we need to go ahead and kind of establish where these points are. So in other words, this right here, let's say that's going to be -1, -2, so this is -3. On the y-axis, see, this is going to be 1, 2, 3, -1, -2, -3, -4. I guess I could go positive, go 1, 2, 3. And on the z-axis, you go up, it's going to be positive. So like this 1, 2, 3. Of course, you go down, it's negative. All right. And so basically, to find the order triple, the first thing you're going to do is you're going to look for your x value first. So your x value is at -3. Your y value is at 4. And so what you're going to do is you're going to try to, I'm going to use a pen here. And what you're going to kind of do is go along these lines. So you know you're going to be at -3. So you want to go along the line, kind of. You want to be parallel to the y-axis. And you want this to be kind of parallel to the x-axis. All right. So that's kind of like your meeting spot in a way. So let's see. Not here, yeah. Okay. And then you want to be up to. So if you're going to go kind of up to the length of 2, kind of. So it'll be right about there. You can see how this kind of like in 3-dimensional space would kind of be about the same point right here. And that's your point. Okay. Y'all see how I did that? Just kind of went up to -3, kind of went across in parallel to the y-axis. Then I went down to -4 and went up parallel with the x-axis. Not exactly, and then got it. And that's my point right there. All right. All right. We want the point 4, 6, 2. 4, 6, 2. Okay. Let's go ahead and plot our points here. So start with our y-axis again. Make sure our y-axis is good and long this time. Our x-axis, let's see if we can do a little bit better job this time with the x-axis. I think that's a little bit better. It's a little bit longer because we need to go forward in 6 and whatnot. And let's see if we can get our z-axis together. I'm gonna start here and go down. Start here and go up. Obviously, I'm drawing in 2 dimensions, so I'm trying to create the illusion of 3 dimensions here, right? So that's a little bit difficult to do. We want the point 4, 6, 2. So we'll start with the x value. X, you're going to go out here, so this will be 1, 2, 3, 4. My y value is going to be 6. So let's see. 1, 2, 3, 4, 5, 6, obviously, right there. Then my z value is 2 again. So we're going to go up 1, up 2. Is this to scale? Not even close, but it'll give us an idea of what's going on. So I know I want to be 4, so I'm going to go kind of parallel to the y-axis at 4. So I'm going to kind of be out here, obviously, somewhere. And then 6, I'm going to be parallel to the x-axis for 6. So it's going to kind of put me about right here. And of course, I want to go up 2, so kind of imagine if I'm going to go up this length, go straight up that length, 1, 2. And so I'll be right about there. Okay, and so that's how you determine points in three-dimensional space. All right, just like in 2 dimensions, we have distance between 2 points. And the distance formula is basically the exact same as the distance formula in 2 dimensions, except the only thing that's different is now that we've got this z part to it, right? All right, the other thing is we look at the midpoint formula, the exact same thing as in 2 dimensions, only we just got to deal with now this z dimension, okay? So let's take a look at these problems. Find the length and midpoint of the following, okay? So we're going to find the length and midpoint of -663 and the length and midpoint of between -663 and -9, -2, and 2. All right, so the first thing we're going to do, so we're to do length, right? We're going to use the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. And once again, just think, I'm just saying the difference between my x values squared, difference between my y value squared, difference between my z value squared. It's just the Pythagorean theorem in a way. All right, just reimagined. All right, so length is going to be, let's see, the square root of, so we got x2, let's call this x2, so we're going to have -9 minus -6 squared plus -2 and 6, -2 minus 6 squared plus -2 and 3, -2, 2 minus 3 squared. All right, so that is, and let's see if we can figure this out. -9 minus -6 is +6, so it's going to be -3 squared. -2 minus 6, that's going to be -8 squared. -2 minus 3, that's going to be -5 squared, okay? Which gives us a square root of 9 plus 64 plus 25, which length then is going to be the square root of, let's see, this is going to be 73 plus 98, square root of 98, which if we put that into our calculator, yeah, I'm not going to reduce it just because it's about 9. So that's the length. Find the midpoint. Now, I could use the formula, right? And probably should, so let me go ahead and do that. But midpoint is so easy. You just find what's in the middle between -6 and -9. Well, -7.5. What's between 6 and -2? Well, it's going to be 2. What's midway between 3 and -2? It's going to be what, 0.5, right? So, I mean, I feel like you could probably kind of work your way through it like that, but let's do the formula anyway. We're gonna run out of space. But let's see if we can figure out. So try to write a little bit small. Midpoint, it's gonna be x2 minus 6, so it'll be like -9 plus -6 over 2 And then you're gonna have the point, let's see, 6 minus 2 over 2. And you're gonna have 3 minus 2 over 2. Which is gonna be, well, let's say about -6 minus, or -9 minus 6. That's gonna be -15 divided by 2, 7.5. 6 minus 2, that's 4. 4 divided by 2 is 2. 3 minus 2 is 1. 1 over 2 is 0.5. All right, let's do the other one real quick. So like, now it should be pretty easy for us. We just plug and chug now, right? You've got an understanding. We can do -4 minus 8 squared. We can do plus -7 minus 3 squared. Plus, we can do 5 minus 4 squared. Square root. All right, this is going to be -12 squared, which is 144. We can do -10 squared, which is going to be 100. And we can do -4 squared, which is going to be 60. So 240 to 260. I think, if my math's not wrong. This is going to be 260, which is about, let's see, 16.1. All right. Then, of course, midpoint. In this case, this is going to be 8 minus 4 over 2. Just adding together, right? 3 minus 7 over 2. 4 plus 5 over 2. That point's going to be 8 minus 4 is going to be 4 divided by 2 is 2. 3 minus 7 is -4 over 2 is -2. And 4 plus 5 is 9 over 2 is 4.5. And that's how you do it. Okay, last but not least, let's look at vectors. Basically, graphing vectors, at least wise, unit vectors in 3D is not really all that bad or that hard, because you're just going to take your components, plot the point, and then draw a vector coming from the origin. All right, what in the world did I just say? Let's walk through it. All right, we want to find vector W, which is -I, -3j, -4k. Now remember, with vectors, we had just I and j. We had two-dimensional vectors. We have a third dimension. We now use k, right? I, j, and k. And you'll find this often in mathematics that we just use the next available letter. So that's why you see X, Y, Z a lot. You'll see U and V together. You'll see A, B, C, and so on and so forth. Okay, I got my X-axis, my Y-axis. I'm getting my Z-axis together. All right, -I, -j, -k. Another way we could write that, just for our sakes in component form, would be -1, -3, +4. Okay, so we can think about it that way. First thing we're going to do is let's look at -1 in the x direction, which is going to be about right here. Right? We can look at -3 in the y direction, which will be 1, 2, -3 right there. And then 4 in the z direction. So we're going to be up a little bit. Let's see, 1, 2, 3, 4. Now, like I said before, we're going to first find that meeting of the two. So we're going to go down here to -3 and go parallel with the x-axis. And we'll do the same thing, go to -1 and go parallel with the y-axis, which gets us to this point right about here. Then we know we need to be up about the same length here. So we go straight up, go up a little bit above it. And that's our point. Now, we're not done. Remember, the vector has to come from the origin and hit that point. So you're going to start at the origin and just draw up to that point and put an arrow on it. That's that vector. That's it. That's all you do. All right. Let's do this one real quick, and then we'll be done. All right. So we've got axis. We've got, let's see. It's not a very good x-axis, but it's all good. We'll figure it out. We got our z-axis. Ooh. Uh-oh. Let's see if we can fix that. All right. We need 3, 4, -2. So first, let's go in the x direction, 3. So we're going to see. So this is 1, 2, 3. We're going to go 4 in the y direction. So let's see. 1, 2, 3, and then 4 is going to be about right here. We need to go -2 in the z direction. 1, -1. -2. All right. First thing we do, once again, you go down to x. You're going to go parallel with y, the y-axis, or try to be as parallel as you possibly can. 4, you're going to try to be parallel with the x-axis. All right. And then you're going to go down by the same amount. Which puts you probably right about here. Now you're going to draw your vector going from the origin to that point. Make sure you got your arrow on there. That's it. All right. Hope you guys really enjoyed that video. We have some more videos on vectors coming out. Don't forget to like, subscribe, just do all of the things, hit the notification bell, and I will see you guys next time.